Hello, welcome back to my channel. Today we are starting something slightly different and going through one of the units for AQA Geography GCSE. You may have seen on my channel over the last few years, I've been putting together kind of revision guides, if you want to call it that, basically the unit, and I talk through each individual unit as we go. And so for AQA GCSE Geography, there are 6 units, so I'm going to go through them. The first is today. I appreciate not all of you study AQA GCSE, however that is the biggest geography GCSE exam board in the UK. Following this will be an EduCast A revision guide for each of the different 8 units, and then again for OCRB. But today we are thinking about physical landscapes in the UK. If you would like to, the notes that I've got in front of me are a revision guide that I have made. If you would like to pick it up, you are welcome to. I've just got it on my iPad here, so you can kind of see what it looks like. If you scroll down, I'm aware that if I move this too far from my face, you can't hear me. So we've got coasts on here. We've got more coasts. Looks a little bit like this. We've got rivers, and then further down here we've got glaciation as well. So I have one of them for each of the different parts of the spec for AQA Geography and everything else. If you would like to pick that up, it is £6 for each of the topics, and that is, you can find it in the link below. So let's get going. The UK's relief and landscape. Relief is a term described to describe the physical height of a landscape, including height above sea level, the steepness of slopes, and the shapes of physical landscape features. The UK's landscape is made up of the action and interactions of both human and natural features. In the UK, we have upland areas, which are lands of high elevation, so steep sides, generally high above sea level, generally characterised by mountains, and we find that in the north and the west of the UK. So we've got the Scottish Highlands, we've got the Lake District, we've got the Yorkshire Dales National Park, we've got the Peak District, and then in North Wales we've also got Snowdonia. In contrast, we have our lowland areas, which are areas of low elevation above sea level. Generally, they are fairly flat, featureless. This is why we find a lot of farms and rolling hills, and we generally find that in the south and the east of the United Kingdom. So moving on to coasts. Waves and their characteristics. So waves are formed by wind blowing over the sea and creating friction at the surface, which causes ripples to form and develop over time into waves. Waves can also be formed more dramatically as a result of earthquakes or volcanic eruptions that shake the seabed and displace this water table above wherever the eruption or earthquake has happened, but they are generally much bigger, we don't see them very often, and we call them tsunamis. So when a wave reaches the coast, generally waves move in a circular movement, a circular orbit, but as they reach the coast and the seabed becomes shallower, that circular orbit becomes disrupted, essentially. And instead of moving in circles, it becomes more elliptical, more like an egg shape. And as the crest of that then falls onto the beach, it causes kind of a disruption in the circular motion and the waves break onto the beach. As it breaks onto the beach and moves up the beach, we call that the swash, and then the water that then comes back down the beach, we call the backwash. So in the UK and around the world, there are 2 main types of waves that we study in geography. First of which is our constructive waves. These are the ones that if you're to go to the beach in the summer, typically if it's a nice summer's day, you'll be able to hear the lapping of the waves on the surface. These are our less powerful waves, typically in a low energy environment, but they help to construct the beach. So as they break on the surface, they take material, sand and sediment up the beach, deposit it, and then they have a weaker backwash. So they don't have as much power coming back down the beach. So we say our constructive waves have a strong swash, deposit a lot of material, and a weaker backwash. Our constructive waves are what build up beaches. It's why we find a lot more sandy beaches, because there's less energy for the sea to be carrying all this material. These are generally formed hundreds of kilometres away from the coast by wind and friction again. In contrast, we have our destructive waves. These are generally found in high energy environments and are made have formed a lot closer to the coast typically. They're associated with storms, especially in the UK. So when we have a storm coming in, which we've had lots of this winter, they are associated with our destructive higher energy waves. Our destructive waves carry lots more sediment. They have the power to carry lots more sediment. And so in a destructive coastline, we generally find more rocky beaches, such as down on the south coast. Our destructive waves, we say, have a weak swash. So as they go up the beach, they typically fall and break quite quickly, but they have a much stronger backwash. So they drag this material off the beach. So they destruct the beach. There are also other processes at work on the coast, one of which is called weathering. You might have heard of this in biology or links to it in chemistry, but we think about this in geography as well. So cliffs collapse on the coast because of different types of weathering. This is the weakening or decay of rocks in the original place, or in situ as we call it, and it's mostly caused by weather factors such as rainfall or changes in temperature. And there are 3 different types of weathering that you need to be aware of. Firstly, we have physical weathering. This is where rocks physically break up, they break down, fall off the side of the cliff, and piles of rock fragments we find at the bottom of the cliff that we call scree. Secondly, we have something called chemical weathering. So as rainwater is slightly acidic, and it will become more acidic with climate change, this slightly acidic water gets into the cracks in rocks and starts to break down the rocks themselves. This slowly dissolves them, and therefore they are weaker and more likely to experience physical weathering. And then thirdly, we have biological weathering. This can be due to the actions of plants or animals. So plant roots could grow into cracks in rocks, widening them, forcing them to break them apart. Or also we have animals such as rabbits that might burrow into cracks in the rock and force them apart as well. Some other processes at play on the coast is something called mass movement, which is the downward movement or sliding of material under the influence of gravity. Both mass movement and weathering provide inputs to the coastal system, so when we have our rocks that are falling down from weathering or mass movement, they can be picked up at the sea or by the sea and used as an agent for erosion. So 4 different kinds of weathering. Briefly, a rockfall feels really self-explanatory. It's when fragments of rock fall off the cliff face, often due to freeze-thaw weathering. We have, secondly, landslides, which is where large blocks of rock slide downhill as a result of gravity and they break apart. We have a mud flow, which is where it's generally rained a lot and there's a lot of saturated rock and weak rock that flows down a slope because of this influence of gravity. It's just too heavy to hold this heavy, wet, sandy clay rock, and it slides down the side. And then very similarly, we have something called rotational slip or slump. So when this saturated soil rock falls down along a curved surface, a bit like a bowl shape, we say that's slumped rather than just flown down. Okay, our coastal erosional processes. There are 4 that you need to be aware of. They are very similar to what goes on in rivers. So firstly, we have hydraulic action. This is where waves crash against the coastline and air gets trapped and compressed in cracks within the rock on the bottom of cliffs. As the waves then hit these rocks, the air is compressed and break apart, weakening the rock. At the same time, bubbles can also form and might implode under high pressure, which again creates tiny jets of water that can weaken and erode the rock, and we call that process cavitation. Second, we have something called corrosion. This is where waves advance and pick up material, and as they break, that material is literally thrown at the base of cliffs, chipping away at the rock over time. So imagine if you're trying to break down someone's sandcastle and you're just literally throwing stones at it. It takes a little bit of time, but it does have the process of erosion. It depends on the type of environment. So if it's a high energy environment where we've got lots of destructive waves, corrosion is much more present. Or if it's a much lower energy environment where we have constructive waves, corrosion is less present because the waves don't have as much strength or energy to hold that sediment to throw it at the base of cliffs, essentially. Thirdly, we have abrasion. This is a sandpapering effect in which sand or sediment is dragged up and down the shoreline, smoothing these rocky surfaces. So abrasion is important in the formation of a wave-cut platform, which we will come on to later. And then the fourth process you need to be aware of is something called solution. So this is where weak acids can dissolve into the alkaline rock. So seawater, again, is becoming slightly more acidic as it absorbs more carbon from the atmosphere, and so seawater is becoming slightly more acidic, and this can wear away the rock in the same way weathering does on the top of cliffs. Solution of the sea can wear down and break down rock. There is another process that you'll probably come across when we are looking at rivers, but it's not as present on coastlines. It does have an impact, but not as much. So this is attrition. Attrition is also occurring within the sea, but it's not really shaping the coast, it's just shaping the other rocks that are happening within the sea. So again, like rivers, when we're thinking about coastal transportation processes, rocks and sand and sediment are carried by the sea in very similar ways that they are carried by rivers. So this will be a little bit of a recap for you. Firstly, we have traction. This is for our much bigger sand, rocks, sediment, where they are rolled across the seabed. We then have saltation, which is where they bounce across the seabed. We have suspension, where smaller rocks, sand and sediment are carried by the sea. And then finally we have solution. This is where really fine sediment is dissolved into the sea and is used as an agent of erosion. The key factors affecting this type of transportation is the energy of the sea and the particle size. In high energy environments, larger particles are able to be transported, whereas in lower energy environments, only the finer sediment can be transported. Okay, let's think about longshore drift. So this is the movement of sand on a beach depending on the direction of the waves approaching the beach. So if the waves approach the beach at a 90-degree angle, the swash goes up the beach and straight back down. However, if the prevailing wind direction is not at a 90-degree angle to the coast, which a lot of the times it isn't, that sand is then moved up the beach at an angle, but because of gravity, it comes back down at a 90-degree angle to the coast. This then starts to move the sediment further along the beach, and we call this process longshore drift. Longshore drift is really important in the formation of beaches and also a depositional feature called spits. So coastal deposition takes place in areas where the flow of water physically slows down. As waves lose energy in bays, in sheltered areas, it can lead to the formation of spits, bars, tombolos, beaches. Here, sediment is no longer able to be carried and therefore it is dropped and deposited because the waves don't have enough energy to keep carrying it, and explains why beaches are often found in bays where the energy of the waves is reduced. Mudflats and salt marshes are often also found in sheltered areas or estuaries behind a spit where there is very little flow of water. So coastal erosional landforms. This is a landform of the feature that has been caused and shaped by the process of erosion, transportation and or deposition. Rocks such as granite and clay form impressive cliffs and headlands because they are more resistant to erosion, whereas our softer rocks, so clays and sands, are much more easily eroded to form bays and on our low energy and low lying stretches of coastline. This can be an important factor in the shape of cliffs as well. Faults and cracks in rocks can either come from tectonic pressures causing rocks to snap, or movement that happens on either side. And when we find these fault lines, erosion can happen a lot more easily. A process of erosion or an erosional landform are what we call our bays and headlands. Our headlands are typically our much stronger rock, and so they are much more resistant to erosion and don't happen as quickly. And so our bays, waves are refracted around these headlands. And so the waves have much more force at these bays, which is where we find our weaker rock, and so our bays are eroded much more quickly. Okay, waves and cliffs and wave-cut platforms. So when waves break against a cliff, erosion close to the high tide line will wear away a cliff to form a wave-cut notch. Over a longer period of time, usually about 100 years, a notch will get deeper and deeper and deeper, undercutting the cliff, and eventually, as that cliff becomes undercut, a little bit like a waterfall, it can no longer support itself, so all the rock above that wave cut notch is fallen and breaks. And there, left behind, we have something called a wave cut platform. Other processes of erosion, or landforms of erosion at the coast, are caves, arches, stacks, and stumps. So, along a coastline, the energy of the waves carve the rock. Over time, if there is a fault in the rock, waves will erode that much more quickly, and it often leads to the formation of a cave. On the other side of this headland, if there is another fault line, which typically there is because of how they're made and how they're formed, erosion will be happening at both sides of that cave. Over time, they can break the whole way through, leaving an arch behind. And as that arch becomes much bigger, the land above it becomes less and less supported, collapses, leaving a stack. And weathering processes on top of that stack can continue to erode, leaving behind a stump. What about coastal depositional landforms then? So beaches are depositional landforms, and they are divided into deposited material that extends from the low tide up to the limit of the storm wave, so above high tide. Waves or beaches can be divided into the foreshore and the backshore. In sheltered bays, we typically find sandy beaches and a gentler sloped beach. If cliffs are eroded and there are high energy waves, this could lead to the formation of a pebbled beach and a much steeper gradient. So if you're down at the sea and you then have to climb up the beach, you'll notice it a little bit more. At the top of the beach is what we call a storm beach, where the strongest waves have deposited boulders and shingle, so this bigger pieces of rock within a storm. There may also be a line of shingle called a berm, and this marks the normal high tide. Okay, sand dune succession, very, very briefly. Some of you will have done this for fieldwork, others not. It's fine if you haven't. Just thinking very briefly. This is again under depositional landforms. So, sand dunes. These are coastal ridges of sand located above the high tide mark, and they are formed and shaped by waves, wind, and the sea. Firstly, we have our incipient dune. These are generally covered with grass and often change due to the shape, due to different weather conditions and wind. We then have the foredune, moving back out from the sea towards inland. These are covered with established soils, large amounts of vegetation, and are not really affected by ocean spray or wind. And then we have our hind dunes. These have a lot more established soils, large vegetation, and have very, very little effect from the ocean, spray, and winds. Okay, what about a spit? A spit is a long, narrow finger of sand or shingle jutting out into the sea from the land. Spits form on coasts where there is significant longshore drift. If the coastline changes shape or orientation, it bends sharply, sediment is then deposited out into the sea. As it builds up and it starts to form the extension of the land. This process continues with the spit gradually growing further and further out into the sea. Strong winds or tidal currents can cause the end of the spit to become curved to form what we call a recurved end to that spit. There may be a number of recurved ends to the end of the spit to form a feature, again called a recurved end. Sorry, getting tripped up on my words there. Marking the end of the previous positions of the spit. In the sheltered water behind a spit, often depositions of mud build up, and often we find salt marshes here as well. Salt marshes are really extremely important wildlife habitats for overwintering grounds for migrating birds in the summer, so we really do want to protect them. So how is that different from a bar? Longshore drift may have caused a spit to grow right across a bay, trapping a freshwater lake behind. An offshore bar forms further out to sea, and waves approaching a gently sloping coast deposit sediment due to friction with the seabed. In the UK, some offshore bars have been driven onshore by rising sea levels, following ice melt at the end of the last glacial period some 8,000 years ago. So each of you will have studied a different coastline within the UK. If you are picking up this revision guide, it's all there for you. So we've got on here the Dorset coast as the case study that I've got here. You may have studied the Holderness coast in the UK. These are all different coastal landforms and stretches of coastline that you can be studying. So if you're studying the Dorset coast, you want to be looking at Chesil Beach as a tombolo. You want to be looking at Old Harry Rocks as your examples of caves, arches, stacks and stumps. We've also got headlands and bays going on here down at Swanage Bay. We've got Lulworth Cove going on here as your examples of bays and headlands. But I would encourage you to go and pick this up. It is page 5 or 6. It looks like this. This is what you're after. So that's got your whole case study in there for you. I don't want to go through it too much because not everyone does this particular case study. So we will move on to managing coastlines, looking specifically to start with at hard engineering. So some hard engineering strategies that we can use. Seawalls. These are physical walls built on the edge of the land to protect the land from the erosive force of the sea. They can either be flat to reduce the energy as the wave goes up the coast. They can be curved to bounce the wave energy back out towards the sea. Pros. They are generally pretty effective at managing coastal erosion and flooding. However, they are very expensive to build and maintain and can cause greater erosion downrift due to waves reflecting off the seawall. Secondly, we have something called rock armour. These are huge boulders resistant to rock, such as granite, placed in front of landforms to absorb and reflect wave energy. One pro, material is deposited because the waves lose energy really quickly, so these can really help to build up a beach. However, again, like most hard engineering methods, they are really expensive to build, and boulders need to be transported from long distances, often elsewhere, to be able to be effective in this region. Thirdly, we have something called gabions. These are wire cages filled with boulders used as coastal defences. They are cheaper and easier to build than many other management strategies. However, the wire cages can erode over time and they're not very aesthetic, so a lot of people don't really like what they look like. And then fourthly, we have groynes. So these can generally either be wooden or concrete. You typically see more wooden ones because they're cheaper. And they are literally large wooden barriers built out into the sea to catch sand and sediment from longshore drift. So it means that this sand and sediment is kept on this particular beach, helping to prevent that coastline from erosion. However, they can be costly, especially the concrete ones, and can cause greater erosion downstream or in a different part of the sediment cell, because that sediment that was once being deposited elsewhere is now no longer, so elsewhere is being starved of sediment. What about soft engineering then? So we have something called beach nourishment and reprofiling. This is where sand and shingle is taken from elsewhere and added to a beach, making that beach more effective at absorbing wave energy, reducing the energy on the coastlines and protecting it from erosion. It often creates a wider beach, which is better at reducing erosion and flooding. However, constant maintenance is needed, especially after extreme weather and high tides, because our destructive waves can then take some of that sand and sediment elsewhere. We have something called dune regeneration, which aims to strengthen sand dunes and protect them from excessive coastal retreat. We often plant marram grass to stabilise the sand, and fences can be used to keep people off these newly planted areas. The aim is to prevent or to create a barrier between land and sea. However, it's often limited to small areas because beach nourishment is expensive and you have to have the knowledge of what plants to plant in different places. And then thirdly, we have something called managed retreat or coastal realignment. This is where we have controlled and intentional areas that we've removed the sea defences to allow certain areas of land to flood and erode naturally. It often creates wetland areas and salt marshes, which we've already looked at being really beneficial biologically for wildlife. It is a very cheap and easy option and no maintenance is needed, and it does prevent erosion and flooding elsewhere. However, the salt can alter other ecosystems, and some land and buildings can be lost, so compensation will be very high. Okay, managing coasts, looking a little bit more at this idea of managed retreat. This is a deliberate policy to allow the sea to flood or erode an area of land of relatively low value. It is a form of soft engineering as it allows natural processes to take place and does not intervene in any way that hard engineering does. Much of the UK coastline does not require expensive intervention, and land may be low value farmland, forest or moorland. And in many cases, these coastal areas can be left alone. We sometimes call it the do nothing approach. However, people living and working in these areas might have to adapt by relocating further inland. It might involve moving mobile homes on a holiday park, a path, a fence, a hole on a golf course. And scientists can monitor these stretches of coastline, helping to reduce the possibilities of conflict between managing the coast and the needs and the views of the local people who are affected. So, an example of a coastal management scheme in the UK, we're going to look at the Holderness Coast very briefly. So, the Holderness Coast is made of a soft boulder clay, eroding at between 1.5 and 2.5 metres a year. It's a very fast eroding coastline. The Golden Sands Chalet Park have retreated more than 122 metres in 25 years, and in some places, the erosion has been even more dramatic. There were 26 villages mentioned in the Domesday Book have been lost to the sea on this Holderness coastline, and the prevailing winds and longshore drift direction in the North Sea erode and transport material further downstream, exposing cliffs to further erosion. To protect settlement and infrastructure, this coastal management scheme has been introduced. So, what is the management strategy? It's looking at two different things. Withensea is a popular tourist town, and over the last 100 years, various sea defences have been built there. The sea defences, including a seawall, which cost £6.3 million, and rock armour to protect the promenade. Wooden groynes were also replaced that have been there for over a century. And in 1991, a £2 million scheme at Mappleton placed granite blocks of rock armour at the cliff's base to reduce erosion. 2 rock groynes were also built on the beach to trap sediment, and the groynes create a more expansive beach which prevents the waves from reaching the cliff. So, what were the effects here? The groynes that were built to trap sediment on Withensea Beach also protect the cliffs from erosion. The effectiveness of these groynes led to a lack of sediment depositing at the Golden Sands Chalet Park, which is south of Withensea, leading to increased erosion there. And then the Mappleton Village and the B1242 have both been protected. However, the area south of the sea defences has created or faced increased erosion. It's gone from 1.7 metres a year to 3.3 metres a year. Farmland south of Mappleton has been lost, including the complete loss of Cowden Farm and Grange Farm. So that is all you need to know about coasts. I am going to split this up into coasts, rivers, glaciation, because there's so much to get through. So do subscribe, you will see that tomorrow. But I do hope it's been useful. As I say, if you would like to pick up this revision guide, the link is down below in the comments. Just looks like this. That is everything I'm going to be going through today, tomorrow, and the next day, and each of the other revision guides that you may or may not need. So I do hope this has been useful. Subscribe if it has, share with someone you think it might be useful for, and I will see you tomorrow. Goodbye.